Okay, good morning, everyone. How did the worksheet go? Any questions about it? Go ahead, either ask or put your question in the chat part, number 3F. Okay, so let me check. 3F and 3E and 4B. 4B, okay, and 2E and 4B. Okay. 2E. Okay, very good. So we answer all your questions. And before, I want your answer to the first part, just to make sure everybody is really on board. So I want your answers. The first one. So I write on a piece of paper and then I see what your answers are. So the first one is E to the 3 ln of x. And the question is, I want you to simplify, no logarithm term or exponential should show. Okay, so let's get going. I want quick answers of those pieces. Okay, absolutely. E to the ln of x is x to the power 3. All of you are correct. So one way you can rewrite it using the property of the log. E to the ln of anything is this anything. ln of e to the x, ln of e to anything, whatever you put in here, is whatever you put in here. That's as simple as that. Now, e to the minus 2 ln of x. 1 over x squared, do you agree with? Yeah, absolutely correct. So one way you can do it is using the property of the logarithm. This could be written, that's one way, ln of x to the minus 2. So I brought the power here, which is x to the minus 2, 1 over x squared. So that's a possibility. Very good. Now, 2 to the power. So the base now is 2. Natural log, log of base 2 of 3 plus log base 2 of 4. Okay, Elizabeth is telling me 12. Anybody else agree with her? Okay, Luke, anybody else? I have Elizabeth and Luke, and I want other student, Austin. All right, so let us work with it. Who would like to unmute and tell me, how did you get 12?
You combine the two logs, you multiply the 3 and the 4, and because the 2 is in the base,
absolutely
and the 2
correct.
is...
All right, we use the property of the natural log, which tells me the following. If you have log to any base of x plus log to any base of y, this is log, of course, it have to be the same base of the product. Sorry. And that's exactly what we're going to use. So we're going to, that's of 3 times 4, so that's 3 times 4. It means 2 log to the base 2 of 12, and this is exactly 12. All right, and the last one, I mean the two last one, and then I take up all your problems. Log base 2 of 64. And finally, ln of e to the 7/5 times the square root of e. All right, I want the first one. What is the log base 2 of 64? The log is the power that gives me 64. That's the log. And 6. I trust you, to the power 6 is equal to 6. Absolutely correct. Very good. Now that's the last one. What do we get? What did you guys get? Okay, Luke is suggesting 19 over 10. Everybody. And let me check. if they are right. Okay, so that's the ln of, I will just do the math again. E, one way to do it. I mean, there are several ways of doing those problems. The square root of E is E to the half. Absolutely, so that's ln. Now, that's the same base multiplication, we add the power. So now we add them. And that will give me ln of 7/5 plus a half, common denominator 10, that's give me 14, 14 plus 5, 19. E to the 19 over 10. ln of E to, it's 19 over 10, correct. Okay, so just this to practice the properties. Now I'll go over, sorry. Now if sometimes I turn the page quickly, you guys let me know on chat, all right? So if you guys are writing, so please let me know on chat if I am fast in turning the page, right? If I turn it, nobody complain, it means you guys are okay, but please feel comfortable to complain. All right, so now let me go to your questions. Is number 3, I have E and F. Very good. Before E and F, let me remind you, because E and F will be actually based on those ideas. If I'm solving something simpler, like D, something like that, equal -3, okay? The easiest way to actually do it is try to isolate the log term, the natural log term. Okay, and then it will be much easier. So if when like in this problem, I'm isolating it, this will give me -3, -4, -7. When I am at this stage, is the problem is fairly easy. So natural log of 5 minus equal -7. So you can here proceed two ways. One way you say, okay, I have a log, I have a term here, I wanna basically get it out of the log. So I take the natural E to the first term equal E to the -7. So because we know that E to the ln of whatever, it's whatever. That's really what I base everything on. When I do this, this is 5 minus 2x. That's the whatever I am talking about here. That's the box I'm talking about. So square will give me 5 minus 2x equal E to the -7. And then I can solve for x. Now that's becoming a fairly simple problem. -2x, E -7 minus 5. X would be, I have to divide by -2. So this would give me 5 minus E to the -7 over 2. The reason I flipped them because I had to divide by -2. So this is a simple scenario. So the idea is isolate the ln term. So now we're going to do number E. So I'm still number 2, number E. And the question is, I want you to solve that. Okay, and I want to use the same approach. I want somehow a way to isolate the ln, but I can't because I have a plus. So what shall I do? Ideas. What shall I do so I can have log of something without having this plus to be problematic? Okay, ideas.
Combine it.
Please, only the student who want to speak in mute. Okay, all right, go ahead. Who was talking? Combine them by multiplying in the parentheses. Very good, combine through. Okay, I like what you guys are saying. There is a plus here. We combine them. When we combine them, it becomes a product. Okay, now I'm basically there because now I totally can isolate my log. It's already isolated. Then I can say that E of the first term is E of the second term. Or you can use the definition. If ln of x to the x minus 1 equal 1, by definition, it means the log is the power of E that gives me 1. It means x times x minus 1 equal 1. But that's really the easiest way. You say E of this equal E of that. All right, and then now we're done. It means, I mean, not done, sorry, but we're there. Equal to E. Oh, how am I going to solve this one? How I'm going to solve this one? So this is x squared minus x equal to E. Okay, how do you want me to solve this? Any ideas? So I combined, I did everything you want me to do. You guys are absolutely correct. Quadratic function, quadratic, move to the left, exactly. So this is the beginning of a quadratic equation. So the only way we solve quadratic equation is basically to set it equal to 0. And usually we factor out, but there is no way we know how to factor out in this situation. So we have to use the quadratic formula, you know, the one that you like. So what's the quadratic formula? Remember, it's minus b plus or minus the square root of b squared minus 4ac divided by the 2a. Okay, so let's do that. So I have two solutions basically, one given by the plus, one given by the minus. So let's first get the one by the plus. So it's minus b. The b is -1, so it's a 1 plus the square root of b squared, it's 1 minus minus plus 4ac. The a is 1, the c is e, divided by 2. Okay? And another solution, it's 1 minus the square root of that. Okay, so we have really to use the quadratic formula. Now, one remark, and I will be actually done, because we're dealing with the ln, we have to make sure that our value of x, with our value of x, those two are defined. It means our value of x will make this one positive and will make x minus 1 positive. So I have to really check that I can plug in those x's in here. So if one of those x's is negative, I can't plug it in here. If one of those x's give me a negative x minus 1, I cannot plug it back in here, so it will not be acceptable. So I need to a little bit see what's the value of x that, you know, work. So this seems to work. It's absolutely positive. So if we can a little bit estimate this one, I will just estimate it. And so I'm just going to estimate it to see if I can actually accept it as a solution. So I will have 1 plus 4e. Oh, 4e. No, this is not going to give me 4e. 4e, do you see how much I use my calculator? Okay, anybody is faster than me. So it's 1 plus the square root of 1 plus 4e. Now I got it, divided by 2. So the first one is giving me 2.2228. And the second one is giving me 1 minus the square root of 1 plus 4e divided by 2. The second one is giving me minus 1.22. Okay? Now, which one is acceptable and which one is not? Is the first one acceptable as a solution? Which means that, can I plug it in here? Yes, because 2.22, the ln of x is positive, so this is defined. And 2.22, if I plug it in here, I will have 2.22 minus 1, which is a positive number. This is absolutely acceptable. This one is not acceptable, absolutely, because the ln, I only can put positive numbers. So if I get a solution which is negative, you know, something is not right. I cannot accept it. So that would be the only solution that you will accept. Okay. So now I take on, you still have 2 more questions, and let me take them all. So it's F. And F tells me solve ln of x plus 3 minus ln of x equal to 2. Okay, so that's again the same situation as we did a minute ago. The only way I will be able to do that is I need to somehow combine my logs. So since I have a difference in here, so the only way I can combine them is I remember the property of the natural log is the log of the A divided by B. Sorry. Okay, so let's do that. It's going to give me the ln of this whole thing equal to 2. Okay, and now I do the same thing. So now I kind of isolate it. So I say E of the first term, whatever the first term is E to the second term. And this is that. So this will give me x plus 3 over x equal E squared. Okay, now I need to solve for x. Very nice. How can I solve for x? So now I'm back to a simple algebra problem. I need to solve for x. So remember, E squared, don't be scared of it. It's just a number. I will not replace it by its value because we're grown up now. We can work with it, but it's just a number. So let's not really worry about it. So how can I solve this equation? Multiply each side by x. It means basically multiply by the common denominator, by the denominator. So we're going to multiply exactly by the denominator. Okay, very good, both sides. So square will give me x plus 3 equal x times E squared. Okay, and now really we have a basic problem, simple problem. So if I ask you to solve x plus 3 equal 3x, I mean, you're not going to have any issue. You combine the x's and you will get 3 equal, for example, 3x minus x. You combine those, you get 2x equal 3, x equal 3/2. It's the same thing here, but instead of having a 3, I have E squared. So I will do the same process. It means 3 equal x E squared minus x. Okay, but now what shall I do? I don't want you to substitute E squared by its value. I want you to keep E squared in the problem. So how would you solve for x?
Factor out x.
I have to factor out x. Thank you very much. Because I don't want you. I want you to keep this. I want you to start learning how to use, not always substitute. And now I am done. Once I factor out the x, I am done. My x is, the value is over x squared, E squared minus 1. Sorry. All right. And now we ask ourselves, can I plug this x back in the original one? So I think we can, because E squared minus 1 is almost 3 over, E is 2.7, 1.8, so E squared is almost 7. So this is almost, now I'm doing it in my head without the calculator. So this is almost a 2, almost, very close to 2. So it will be acceptable because this is positive and 2 plus 3, of course, is positive. So this value of x is acceptable because it doesn't give me any issue with the initial problem, because I need the x that I can plug it here. So I'm gonna make sure that my x, because the ln makes sense only for positive numbers, that my x will work. Okay? Questions, please, before we go to the last problems you guys asked me. All right. So the last problem is about the inverse, which is actually, I want to review it, just keep reviewing how to find the inverse. So this is the problem. B. And find the inverse of the following function. 10 to the x over 1 plus 10 to the x. Okay. So what does it mean to find the inverse? So it means that I have a function g. I don't know how it looks like, this g. Okay, so whatever, if let us say it looks like this, a one-to-one function. Find the inverse, it means if I know the output, I need a way to find the input. That's really over and over the inverse. So it means I need to find y as a function of x. So here we're gonna set y to be equal 10 to the x over 1 plus 10 to the x. And of course, we have to solve for x in terms of y. Means I know my output, I know it. I need to find the input. That's really what the problem is about. All right, so this is basically a simple problem. Not simple, but why? I know why. I know why. I want you to find the x. I know the y. It's the x I am after in terms of y. So what do you want me to do? Ideas? Ideas? Multiply both sides by 1 plus 10 to the x, okay? Because we're gonna get it with denominator, so I follow verbatim what you tell me. Equal 10 to the x, that's absolutely the right approach because, you know, we need to solve. And then remember, we have to solve for x and then take the log of each side. Oh, if I take the log of each side, it actually gets me nowhere. Why? Why it gets me nowhere? If I take the log of this, of 1 plus 10 to the x times y, okay, you know, when we do the operation, it has to get me somewhere. What will I get? So log of this, it means 1 plus 10 to the x plus ln of y. I'm stuck because I have 1 plus 10 to the x. I cannot get my x out. So taking the log from both sides will not improve my problem. Will not improve my problem. Yes, Elizabeth is right. What we want to is, because we're solving 10 to the x, actually I would like to do is to isolate the exponential term. Because my unknown now is an exponent, and to solve a problem that involves an exponent, I need to isolate this term, and then I can solve it. So to isolate it, I need to distribute the y. Then to the x, okay? I need to isolate this. So this is my unknown, basically. This is the piece I need to isolate. And then how can I isolate it? We did it a minute ago. Remember, y is the one you know, x is the one you are after. So what shall I do at this stage? It's very much like the one I did a minute ago. Okay, so if I give you, yes, you're right, Elizabeth, but I want to make everybody, like, suppose I know y. And I ask you to solve this equation. No, I ask you to solve this equation, easier one. 2 plus 2 times 10 to the x equal 10 to the x. If I'd ask you to solve something like that, what would you do? Since this is an exponential, you try to isolate your exponential. So you can put, this will become 2 times 10 to the x minus 10 to the x equal minus 2, 10 to the x, sorry, the numbers are not working here, but let me put minus 2, for example. So it's going to give me minus, so minus 3, 10 to the x equal minus 2, 10 to the x equal 2 over 3. So if you don't have a y, you just have a number in here. So the way you do it, you're going to isolate your 10 to the x and solve. And that's exactly what your classmate is telling us. I need to find a way to isolate 10 to the x, because that's my unknown. So I can bring everything to one side. So I will put 10 to the x minus times y. Now I need to isolate the 10 to the x, and the only way to do it is to factor out the 10 to the x. Okay, when I factor it out, I can isolate it. So now I can get 10 to the x equal y over 1 minus 1. Now I can take the log. Now I can take the log. Now I am in a good line. So now I can say that ln of 10 to the x equal ln of y over 1 minus y. Now ln of 10 to anything is x, ln of 10 equal ln of this. So it looks a bit complicated, but it means my x is 1 over ln of 10 times the ln of y over 1 minus 1. Okay, so it's mainly an algebra problem more than anything else. So what is my function? F inverse. Now, if I want to use, I don't care about the name of variable you use. If you use y for the name of the variable, this is 1 over ln of 10 times ln of y over 1 minus y. If you want to use x as the name of the variable, then f inverse of x, if you use x, would be 1 over ln of 10 ln of x over 1 minus x. So yeah, I can do that. Yes, I can do that. So that's the end of the problem. Okay. So Luke asked me, and rightfully so, instead of using the natural log, can I use the log base 10? And the answer is, of course you can. So, okay, I'll keep this. Or, so let us see, or you can do like that. If you have 10 to the x equal y over 1 minus 1, then take log base 10. It means the common log of 10 to the x, which is log base 10 of y over 1 minus y. And log base 10 of that would give me an x equal log base 10 of 1 over 1 minus y. So of course you can take the common log. So f inverse of y, another way, okay, so you can use either one, and it doesn't matter to me. Both will be absolutely accepted. Okay. Please ask questions if you don't follow. I don't see your faces, so I cannot judge you very well. So please feel comfortable to ask. If I'm going fast, you let me know. Okay. All right, so let's move on. The last piece of I want you to know about the natural log is how the graph of it. Knowing the graph of function is actually very important. Can you move the paper up? Which one, Markisha? This one? Markisha? Yes, okay. Here we are. Now, the graph that I want you to know so far is the exponential a to the x, sorry, b to the x, I remember we called it b. And of course, e to the x always. And b to the x, the graph was, it depends whether b is bigger than 1 or greater than 1. So if b bigger than 1, it was an increasing function. If it's less than 1, it was decreasing function. E to the x is such an important function that I want you to know its behavior absolutely by heart. What characterizes it is when x take large negative value, it becomes fairly close to 0. Okay. Now the natural log or log base 10, because they look the same, let us see exactly how they look, and then we move on. Okay. Makisha, can I change papers? Thank you, thank you. Okay, now the graph of the natural log. And I will do it just basically by plugging in values because I like to do that. So I'm going to draw the common log because the values are easier, and then the natural log will look exactly the same. So let us take the natural log, sorry, the log of base 10, and let us graph it. The first important thing we want to know is the domain. Crucial. What is the domain? So my function is, so that's my function, I write it again, is log base 10 of x. Okay, first, what is the domain? The log makes sense only when x is positive. So the domain is all values of x such that x is strictly positive. In interval notation, 0 plus infinity. Okay, important. So now let us see the value of the natural log. What are some important values? The one that we know. Okay, I cannot take negative value. At 1, so this is my x log base 10 of x. All right, what's the value at 1? Quickly. What's log base 10 of 1? Quickly, it's absolutely 0. And this is because 10 to the power 0 equal to 1. And the log is nothing more than the power. So that's a nice value to know. What is log base 10 of 10? Quickly, it means 10 to which power? Give me 10. It's absolutely a 1. So at 0, I am right here. At 10, I mean, wow, this is totally off scale. So I'm going to put 1, I'm going to cheat a lot. So I'm going to put 1 here. Let's get that. 10 is somewhere here, very far away, and my function takes the value 1. Okay. If 10 is 2, if my input is 100 or 100, so we are really far away, what's my output? 2, because 10 to the power 2 is equal to 100. So at 100, my function takes only the value 2. So my function seems to be going like this, at least for x bigger than 1. Okay. Do you think it's going to keep going to infinity? Because it seems to be very slow. Do you think it's going to grow a lot? You know, at 100, the value still, the output is still 2. Do you think it's going to go, takes very large value? Means my question is, do you think the log will ever take the value, well, let's pick a big value, right? A value 100. Yes or no? Yes, give me the input. That gives me an output of 100. So my question is, you know, at 10 it's 1. At 100 it's 2. But that's the function keeps growing. I mean, it really keeps growing. Who can give me an input where the output is 100? Okay, if I take 100 to the power 100, a huge number, needless to say. The output is 100. So the function keeps growing, but the function keeps growing very, very, very slow. Okay, I tell the student it moves like a sloth. It moves very, very, very slowly. Now, what happens when x takes values less than 1? What is the output? Okay, we have to understand the output of the function. All right, I'm going to take specific value because to make simple. Let's see, suppose my input is 1 over 10. Which is very close to 0 because I'm only allowed value close to 0. What's the output? And the reason. It means what power, that's what I'm asking, of gives me 1 over 10. Very good, it's minus 1. So at 1 over 10, which I'm very close to 0, my output is minus 1. Okay, that's my output. So my function seems to be going like that. If I take something even closer to 0, 1 over 100. So, I mean, you see that my scale is off because I'm taking small number, 1 over 100. What should be my output? Negative 2. Means my function is this value. If I take 1 over 1,000, it is minus 3. So I can take smaller and smaller, larger and larger smaller and smaller number, and my function seems to be going down and down and down. So that's going to be the graph of my function. So when x, that's important, 2 things. When x becomes close to 0, to 0, my function, what happened to it? What type of value is taking? When x becoming close to 0, my function is taking values. I want to finish my sentence. I want to finish my sentence. What type of values is the function taking when x is very, very, very tiny? Okay, I'm not having answers. Asymptote, this one I'm gonna hold on to it. Asymptote of 0, I wanna go with Elizabeth. Take negative values. You're almost correct, Elizabeth, but I want something else. It takes negative, what type of negative values is take? Right, it takes large. When x becomes log s, takes large, very large negative values. Very large negative values. And very soon, which is next week, but we're going to rewrite this in the following format. Then when x become close to 0, so we're going to introduce this notation, then the natural log goes to minus infinity, which expresses the idea that is taking not only negative values, that's absolutely correct, but large negative value, large negative value. Okay, so that's really the graph of the ln. What's two things about it? This one important thing about it. The other important thing about it is that when x takes large positive, it means when x become close to plus infinity, it means takes large positive. The function itself takes large positive value. So it means this one take large positive. That's really what it means. And then the other thing is that when x is greater than 1, the function is taking positive values. And when x is between 0 and 1, the log is negative values. So that's really, okay, so that's really the whole picture about the graph of the natural log. So it's negative between 0 and 1, 0 in here, and then it takes positive value. This is the common log. The natural log is exactly the same. So ln of x, I will just graph it, is exactly the same approach. I picked the common log because the number are a little bit easier to work with. Okay. So ln of x. So how is the graph of ln of x is? So y equal ln. And again, I want this graph totally memorized, even though you guys can always use your calculator, but if I were teaching you face-to-face, you wouldn't have been allowed to use it. So ln of x, at 1, it is 0. And the graph is, it's called the domain is positive. It starts from minus and it goes all the way like this. So that's the graph. Okay. So now that we know how the graph of ln, we can actually start doing other graphs. So I'm going to ask, first of all, the following questions, because I want to emphasize the idea of domain, and then we're going to graph the ln, but by shifting them a little bit. So first, my question will be only with the domain, because it's important to know the domain. So find the domain of the following functions. All right. F of x equal ln, so that's the natural log of, let us say, I'm just plugging anything here, 3x plus 4. I'm not graphing for those, I just want to find the domain. So what's the domain of this function? It means which inputs are they allowed in this scenario. Okay, I'll give you a minute to figure out the answer. To ask yourself, what restriction do we have on the input in whenever you have a natural log term? Okay. Any answer so far? Every one of you is responsible. Every one of you should be able to think through that. I'm getting one answer from Elizabeth. I want somebody else. Elizabeth, you have a stupid mistake. Yeah. Anybody else? Okay, so where did Elizabeth cut her answer from? What is the restriction? The only thing, input, we can put inside the log are positive numbers. So to find the domain, it means this function makes sense. We need to find the value of x that makes what's inside the log positive, crucial. Okay, because any number that makes this like the square root in a way, it doesn't work. So this means that x has to be strictly greater than minus 4/3. Okay, so anything like if I take x to be -2 and I plug it here, I will have -6 plus 4. Forget it. That's a negative number. It's not in my domain. So my domain, the only value I can have are the values bigger than minus 4/3. So in interval notation, if you want, and as I said in your quiz, you can write either notation. So in the interval notation, the domain is minus 4/3 open plus infinity. Okay. Now another function, suppose I take f of x to be ln of, again, let us say x squared minus whatever, 4. Something I've done several times. Okay, all of you, I want the, yeah, I give you a minute to give me the domain. Again, what is the restriction on x? That's how you have to think. 2 to infinity, 2 to infinity, x bigger than 2. Okay, I'm still waiting because I kind of like your answer, but not quite. You're missing part. You're giving me half the answer. Half the answer. Talon, I don't quite understand your answer. Okay. All right. Very good. Now we're getting there, because let me ask you, if I give you x to be -3, is x equal -3 in your domain? If I plug in -3 for x, I get 9. 9 minus 4, that's absolutely a positive number. Now we're doing, Markisha, you told me no. Let me ask the question again. If is x equal -3 in the domain? Okay, let's plug in -3 in here. What do I get? X squared minus 4, if x is -3, is 9 minus 4. Positive. So it is in the domain. It doesn't give me anything. All right, so what's the domain? Now I'm getting a lot of the correct answer. The domain is all the x's such that x squared minus 4 is strictly positive. And this is something I did at the beginning of the semester. X squared minus 4 positive, if you are solving it, it means x squared has to be bigger than 4. And to solve this particular one, which is, it means that the square root of x squared bigger than 4, but the square root of x squared is not necessarily x, it's the absolute value of x. Now, which axes have their absolute, sorry. I have a stupid mistake. You should have screamed and yelled, but you didn't. Okay, but which value has absolute value bigger than 2? It means if the absolute value is bigger than 2, it means x could be bigger than 2, but also it can be less than -2. Okay, so the domain, as I said, now you can write it in 2 ways. So one way you can write the domain is as follows. Okay, so the domain, either you can tell me all the values of x such that x bigger than 2 or less than -2. Or in interval notation, it's from -infinity to -2, but you want also everything between 2 and infinity. And the way we write this in interval notation by using the sign, which means the union. Union means both of them. I want x could be here or it could be here. That's what it means. So the union, it means the or. That's the or here. It means x could be here or it could be here. Okay. Now, the last question, which is simple. I want you to graph the following. So again, shifting and scaling. So graph, find the domain and graph. So the last problem is find domain and graph the following. F of x equal natural log of x plus 4. Let me bring it down a little bit, -3. Okay, so find the domain and graph. So that's again back to scaling and shifting and stuff like that. And so first the domain. The domain is, I care a lot about the domain because we have to know which axis I can put for input. So my domain here is, I need this here inside to take only positive value. So my domain is, we need to solve x plus 4 strictly positive. It means x is strictly less than, strictly bigger than -4. So my domain is all x's such that x larger than -4, or in interval notation, -4 plus infinity. Very good. Now, the graph. I want you to sketch the graph by using shifting and scaling and stuff like that. So, and this one, you want to sketch it starting from the LN graph. So how shall we get this graph from the LN graph? So the graph. Okay, so before we do it, let's see how we get it. What would you do first? So we're going to start from Ln of x. Then what do we do next to get this graph? Quickly, and then we graph it. Shift down by 4. And then left by.
No.
Uh-oh. No, look.
Left 4, down 3.
Right. First, you have x plus 4 here. It means you have to shift left by 4. So you start with Ln. First, you shift left by 4. If you shift left by 4, then it means you're getting Ln of x plus 4. Okay, so Ln of x plus 4, you have to get it by shifting left by 4. And finally, you have to shift down by 3. When you shift down by 3, you will get the Ln of x plus 4 minus 3. Be careful, shifting and scaling is on your quiz tomorrow. So we start with Ln. Then I have to shift left by 4, which give me this function. And then shift down by 3, which will give me that. Now I just have to graph it very, very carefully. Okay, so I will take another piece of paper. We're killing a lot of trees in here. All right, another sheet of paper right there, and we do it. So, and let us do it. I'll follow verbatim. So I start with the graph of Ln, and the graph of Ln, we know that at 1, it's a 0. And this line, so this is very, I'll shift the paper in a second. So we know that it's very close to 0. So usually we're going to say that y equal to 0 is an asymptote, x equal to 0, or the y-axis is an asymptote. because the graph is getting very close to 0 and it's never hitting it. So this is my ln x graph. And then I need to shift by 4. So this has to be shifted. So the 1 will go here. So we're going to shift now. My 1 is going to go here. And this axis is actually going to be shifted by 4 units. So this axis will become right there, basically. So this axis will be shifted. So everything is going to be shifted. So now I'm just going to shift by 4. And why is this -3? Because the 1 shifted by 4 is going to become -3. And this here is the -4. And it makes sense because this is ln of x plus 4.
Don't you also have to go down 3?
Yes, absolutely, absolutely. I'm doing it step by step. You're absolutely right. I am right here. Okay, and then I'm going to go down. Yeah, okay. Absolutely. Okay, so this is only ln of x plus 4. And it makes sense because the output, this one, makes sense only for x bigger than -4. So that's why I only have this piece of the graph. And finally, I need to shift down by 3 units. So let us shift down by 3 units. So this is going to go down by 3. Everything is going to go down. So everything is going to go down. So let's see what we're going to get at the end. Okay. So at the end, so this is going to stay here. So this will be still in asymptote, but I'm going to go down by 3. So we're going to go down somewhere by 3. And this is ln of x plus 4 minus 3. Okay. And that's really the graph. All right, so I definitely have to stop at this point. Any questions concerning anything? All right, so for tomorrow, of course, you guys have a quiz. I want you to finish the worksheet that I assigned, which is on Blackboard. So I gave you up to 4. So you finish the last 2 problems, which are basically domain and graph. And your quiz will cover everything we did this week. So basically the quiz will cover scaling and shifting and all this stuff. And then exponential, inverse, and logarithm, all of it. Okay, so your quiz will cover all those ideas. So make sure you review them. For those who did not do my lab problems, please, homework, please do it. They are due tomorrow, tomorrow at like 11:59. And there's actually mainly only the graded one, there's only one to grade, that the grade will be considered, and the one about scaling and shifting, even though the grade is not, it will not be for grade, that as I promised you at the beginning, but you will be tested on it. So please do it. It's not for grade, so just do it and see if you can do it. Okay, and then exponential, inverse, and logarithm will be based on the worksheet that I gave you. Okay. Tomorrow we will review trigonometric function. It will be like a crash course, very quick. And then next week we start the idea of limits and continuity. Any questions before we let go? Any questions? Okay, as you know, I have office hours after class. If you have any problems, please join me. Okay, and bye for now.